Welcome back to Neural Intel.
Good to be back.
Today, we're diving deep into something quite technical, but really fundamental. How we evaluate spoken dialogue models.
Right, the advancements in evaluating them. You shared some fascinating material on this.
Exactly. We've got this research paper, WavReward, Spoken Dialogue Models with Generalist Reward Evaluators. And our mission, really, is to unpack the technical significance here. Because how we measure these things, it really matters.
It absolutely does. This paper tackles a pretty crucial gap. Traditional methods often just look at the text transcript.
Yeah, and that misses so much, right? Like the emotion, the tone, all those acoustic cues that humans use constantly.
Precisely. Think about sarcasm or excitement or even just hesitation. Text alone doesn't capture that.
So this WavReward approach, it's trying to evaluate both the, let's say, IQ, the accuracy of the information, and the EQ, the sort of emotional intelligence using the audio itself.
That's the core idea, evaluating spoken dialogue using audio language models.
Okay, let's break that down. The central problem they're addressing is that current evaluations are text-heavy and, well, insufficient for real human-computer speech interaction.
Exactly. They fail to capture that non-textual layer. How something is said is often just as important, sometimes more important than what is said.
So WavReward comes in. It's a reward model built on audio language models. How does that work conceptually?
Well, the key insight is using a model that intrinsically understands audio to evaluate another model that produces audio.
Okay, that makes sense. Fighting fire with fire almost.
Sort of, yeah. It allows you to assess both things simultaneously, the textual accuracy and the acoustic appropriateness. Are the words right, and does it sound right?
The paper mentions deep reasoning and nonlinear rewards. What's the technical thinking behind incorporating those?
Good question. The deep reasoning part, it suggests the model goes through a more complex analysis before assigning a score. It's not just a surface-level check.
Like considering multiple facets of the response.
Exactly. And the nonlinear reward mechanism. That's interesting, too. It means the model doesn't just give points linearly.
Meaning?
Well, think about it. A response might have the perfect information but sound completely robotic or, worse, actively inappropriate in tone.
Right.
A nonlinear reward system can penalize that mismatch more heavily than, say, a minor grammatical slip-up delivered with the right tone. It allows for finer-grained judgment based on the severity and type of error.
I see. So it can weigh different kinds of mistakes differently. More like how a human might react.
Precisely. Now, to actually train this WavReward model, they needed data. They created something called ChatReward 30K.
Okay, a new data set. Why couldn't they use existing ones?
Well, most existing dialogue datasets are primarily text-based, or if they have audio, it might not be annotated or diverse enough for the specific task. They needed something designed for evaluating spoken dialogue quality, including all those acoustic nuances.
So what makes ChatReward 30K special? What kind of information does it contain?
It's quite rich. It covers various acoustic dimensions, things like speaker gender, age, different languages and accents, variations in pitch, speed, volume.
Wow. Okay.
And crucially, emotion. It tries to capture a wide spectrum of how things can be said, which is vital for training a model like WavReward to recognize good and bad examples.
So it's mapping acoustic features to dialogue quality. The paper also mentions multi-sample feedback in the reinforcement learning part. What does that entail?
Right. So instead of just looking at one single response from the model being evaluated for a given input, WavReward is trained by comparing multiple potential responses and their associated scores.
So it sees a range of options.
Exactly. It helps the reward model learn more effectively what distinguishes a slightly better response from a slightly worse one, or a great one from a good one.
Yeah.
It provides a more nuanced learning signal.
Okay, that makes sense. Like getting multiple opinions helps you refine your own judgment. Can we dig into the WavReward architecture a bit? It's based on Qwen 2.5 Omni?
Yes, it uses the Qwen 2.5 Omni audio language model architecture as its foundation. So it takes the spoken dialogue, turn the user's utterance, and the system's spoken response as input. And then it learns, through training on ChatReward 30K using reinforcement learning, to predict a quality score for that interaction.
And they use chain of thought reasoning during this process. How does that fit in?
Right, the chain of thought aspect. It basically means the model is encouraged to internally generate intermediate reasoning steps.
Like explaining its logic to itself.
Kind of, yeah. It analyzes the content, the acoustic features, sort of step by step before outputting the final score. It's thought to help improve the accuracy and robustness of the evaluation. It's not just a black box prediction.
Interesting. So it's trying to mimic a more analytical evaluation process. Going back to the WavReward 30K dataset you mentioned, its acoustic richness. But the paper also stresses it evaluates both understanding and generation. Why is that dual focus important?
It's critical. Evaluating understanding, speech-to-text accuracy is standard. Did the model hear correctly?
Sure.
But this data set also lets you evaluate the generation side, the text-to-speech quality in context. Did the model say the right thing in the right way? Did it match the requested tone, if any? Did it sound natural?
So it completes the loop input understanding and output quality.
Exactly. And it includes these implicit dialogues. What are those?
Implicit dialogues. These are scenarios where key information isn't in the words, but in the way they're spoken. The emotional subtext, like if someone sounds really stressed asking a simple question.
Precisely. Or sounds hesitant or maybe overly cheerful. A good dialogue system should ideally pick up on these implicit cues. WavReward 30K includes examples like this to test if the model can handle that subtlety, both in understanding the user and generating an appropriate response.
So it's pushing towards evaluating that EQ aspect we mentioned earlier.
Definitely. And the dataset has both positive and negative examples, which is standard but essential for learning.
Right. You need to know what not to do as well.
Exactly. And crucially, it relies on human expert scoring for the ground truth.
Which provides quality control, especially for subjective things like tone appropriateness.
Absolutely. Getting that human baseline is key for ensuring the dataset reflects meaningful quality judgments.
Okay, so we've got WavReward, trained on this specialized WavReward 30K dataset using these advanced techniques. How did it actually perform? The results look pretty strong.
They were quite striking, yes. WavReward showed a really significant improvement over previous state-of-the-art methods.
Like the comparison with the base Qwen 2.5 Omni model.
Right. Objective accuracy jumped massively from around 55% for the base model to over 91% for WavReward on their tests.
Wow, that's a huge leap.
It is. And perhaps even more telling, in subjective A/B tests where humans directly compared evaluations, WavReward scoring was preferred something like 83% of the time.
So humans generally agreed more with WavReward's assessment of quality than with other methods.
Exactly. It suggests its evaluations align much better with our own perception of what makes a good spoken interaction.
The paper also mentions ablation studies.
Yeah.
What did those tell us about why WavReward works so well?
Ablation studies are where you systematically remove parts of the model to see how performance changes. It helps pinpoint what's contributing most.
Right. Isolating variables.
Yeah. And they found that removing the chain of thought reasoning or the multi-sample feedback or that nonlinear reward system, each of those individually caused a noticeable drop in accuracy.
So it's not just one magic bullet, but the combination of these different technical components.
It seems so. Each piece plays an important role in achieving that high performance.
And they tested it on real-world data, too, not just the curated data set.
Yes, which is crucial for validating practical relevance. They tested it on real human-machine dialogues involving models like Llama Omni and Kimi Audio.
And how did it fare there?
It still achieved high accuracy, around 80%, which suggests it's pretty robust and generalizes well beyond the specific training data.
And subjective tests on that real data also backed it up.
They did. Human preference, again, leaned heavily towards WavReward scoring, confirming its alignment with human judgment, even in messy, real-world conversations.
Okay, let's pull this together. For you, the listener focused on the technical side of AI. What's the big takeaway here?
Well, WavReward really marks a significant step forward in technically assessing these increasingly complex spoken dialogue systems. We're moving beyond just text metrics.
Right, we're starting to measure the things that make speech feel natural, the acoustic qualities.
And the development of WavReward, alongside that WavReward 30K dataset, gives the research community much better tools. Tools to build and properly evaluate more natural, maybe more context-aware spoken interfaces.
Which could lead to, voice assistants that don't just understand what you said, but maybe how you're feeling when you say it and respond more appropriately.
That's the direction this kind of work pushes towards. And technically, what's really fascinating is this idea that audio language models themselves can be effective evaluators. It opens up possibilities for maybe self-assessment loops within these systems.
Like a model analyzing its own speech output quality based on acoustic nuances.
Potentially. It's an interesting avenue. So the technical summary is, we're seeing more sophisticated holistic evaluation methods emerge, leveraging audio models themselves, trained on richer, acoustically diverse data, using techniques like deep reasoning and multi-sample feedback.
It's definitely pushing the boundaries of how we measure progress in this space.
Absolutely.
So for your own further exploration, maybe consider the technical challenges still remaining. Creating data sets that truly capture all the subjectivity and complexity of good conversation, especially emotional nuances, that's still incredibly hard.
Definitely. How do you quantify subtle appropriateness perfectly?
Right. How might future research build on WavReward's technical foundations to tackle those even finer-grained complexities? That's something to mull over.
A good thought to end on.
Until our next deep dive, remember to check out the linked webpage for more on the latest AI and ML research.